Victories of the day. March 19th. Victories of the day, March 19th. 1. The establishment of the Standard Time Act, March 19, 1918. The United States officially codified the Standard Time Act, which not only validated time zones but also introduced daylight saving time as a scientific method of energy conservation. Before standardized time, every city kept its own solar time based on when the sun was overhead. This caused temporal chaos for the growing railroad and telegraph industries, leading to frequent train collisions and communication errors. The world was divided into 24 zones, the time zone grid, each 15 degrees of longitude wide, synchronized to the prime meridian. Chronometry and network synchronization were implemented. This was an early exercise in system efficiency. It treated time as a global utility rather than a local observation, allowing for the coordination of a modern, industrial society. This act is the legal ancestor of the atomic time synchronization used by the Internet and GPS. Without the rigorous standards established on this day, global digital networks would be impossible to synchronize. 2. The birth of the Joliot-Curie nuclear synthesis, March 19, 1935. Frederick and Irena Joliot-Curie received formal recognition for their discovery of artificial radioactivity, proving that stable elements could be made radioactive by human intervention. Science previously viewed radioactivity as a gift of nature, something found only in rare elements like radium or uranium. It was believed that the stability of an atom was a permanent state that humans could not alter. Alpha particle bombardment of aluminum. By firing alpha particles at aluminum foil, they turned it into a radioactive isotope of phosphorus. The nucleus of an atom could be re-engineered by induced radioactivity. It broke the barrier between biology and physics, as scientists could now create tagged radioactive isotopes for medical use. This is the foundation of nuclear medicine. Every PET scan, thyroid treatment, and cancer radiation therapy used today relies on isotopes created using the artificial radioactivity techniques pioneered on this day. 3. The first isolation of plutonium, March 19, 1941. Glenn Seaborg and his team at UC Berkeley finalized the first chemical identification and isolation of plutonium, element 94, a discovery that would change the course of the atomic age. Until 1941, the periodic table ended at uranium. Scientists theorized that transuranic elements might exist, but they lacked the high-energy equipment to forge them. Earlier attempts often confused new elements with existing radioactive isotopes. The 60-inch cyclotron was used. By bombarding uranium-238 with deuterons, heavy hydrogen nuclei, the team produced neptunium, which then decayed into plutonium-239. The actinide concept, Seaborg realized that these new heavy elements didn't fit into the main body of the periodic table but formed a new row underneath, sharing similar chemical behaviors. Plutonium-239 is the primary fuel for nuclear reactors and weapons. However, plutonium-238 is also used as a long-term heat source, RTGs, for deep space probes like Voyager and the Perseverance Mars rover, providing power where sunlight cannot reach. 4. The launch of Ranger 9, moon mapping, March 19, 1965. NASA launched Ranger 9, the final and most successful mission of the Ranger program, designed to provide high-resolution images of the lunar surface before impacting the moon. Early lunar missions, Rangers 1 through 6, were plagued by camera failures and guidance errors. Scientists lacked the close-up data needed to determine if the moon's surface was solid rock or deep, treacherous dust that would swallow a landing craft. A suite of 6 high-speed television cameras and a high-gain antenna were implemented. Ranger 9 was unique because its images were converted for live television broadcast, allowing the public to see the moon's surface rushing toward the camera in real time. Photogrammetry concepts were used. By taking a rapid sequence of photos at decreasing altitudes, scientists could calculate the exact depth of craters and the slope of the terrain, essential for choosing the Apollo landing sites. Ranger 9's impact in the Alphonsus crater provided the first evidence that the Moon had a complex volcanic history. This suicide mission logic paved the way for the Lunar Reconnaissance Orbiter and all modern planetary mapping. 5. The discovery of CFC's impact on the ozone layer, March 19, 1974. F. Sherwood Rowland and Mario Molina published their groundbreaking research in Nature, proving that chlorofluorocarbons, CFCs, were migrating to the upper atmosphere and destroying the Earth's ozone layer. Before 1974, CFCs, used in aerosols and refrigerators, were considered miracle compounds because they were non-toxic and chemically stable. Scientists failed to realize that this very stability allowed them to reach the stratosphere intact, where solar radiation would finally break them apart. The study utilized atmospheric chemical modeling. The key components were the chlorine atoms released from CFCs, which acted as a catalyst. One single chlorine atom could destroy 100,000 ozone molecules. The Rowland-Molina hypothesis posited that UV light triggers a photochemical reaction. This proved that human-made chemicals could alter the global environment on a planetary scale. This work led directly to the Montreal Protocol, the most successful environmental treaty in history. Today, the ozone layer is actively recovering, preventing millions of cases of skin cancer and protecting global agriculture. 6. Scientist of the Day, Mario Molina, 1943, 2020. Molina was the first to realize that CFCs weren't just floating away, they were knocking the teeth out of the Earth's atmospheric shield. He didn't stay in the lab, he fought for the Montreal Protocol, proving that a chemist's data could be the most powerful tool for global diplomacy. His work on March 19 bridged chemistry, meteorology, and environmental science, showing that the most important scientific discoveries are often those that protect the very air we breathe. Because of his research, the ozone layer is one of the few environmental success stories where the theoretical failure of a chemical was identified and corrected in time to prevent a global catastrophe. Victories of the Day. March 19.